Welcome to my channel. In this video, we are going to derive mirror formula and magnification. Now, why do we need this? Now, from the sign convention, this is the thumb rule that we can understand that all the distances towards right of the mirror are positive, towards the left are negative, and towards up are positive, towards down are negative. Now, with respect to that sign convention that I discussed in my previous video, depending on the object which is above the principal axis, positive, image if it is real and inverted below the principal axis like this, and it will be negative, and if the image is behind the mirror and above the principal axis, it is virtual and erect, and it will be considered positive. So, with this sign convention, we cannot measure different distances all the time. So, a single formula is used to measure different distances, and that formula, a relationship between object distance, image distance and focal length, is what we call it as mirror formula. Now, what is mirror formula? It gives a relationship between object distance u, image distance v and focal length f of a spherical mirror. So, it is a relationship between u, v and f. Now, why do we need that? This single formula, we can measure all different things related to spherical mirrors. It is used to identify the position, size and nature of the image, where exactly the image is positioned and what is the size, whether it is enlarged or diminished, and what is the nature, whether it is real or inverted. So, these things can be found out from this formula. And what is this formula? 1 by f is equal to 1 by u plus 1 by v. Now, let us derive this particular formula. For that, let us look at this picture where I have drawn. Now, this I already discussed in one of my previous videos. So, AB is the object and A dash B dash is the image formed, and this image is formed in front of the mirror and on the same side of the object and below the principal axis. Therefore, this image is real and inverted, and A dash B dash is the image, so real and inverted, and then MN is the surface of the concave mirror. We have considered P is the pole, F is the focus, C is the center. Then if you look at these distances, now this is the incident light falling on the mirror, gets reflected and passes through focus, and like this it comes. Then if you consider another light ray coming from the object A, passing through C like this and falls normally onto the mirror at N, and because it is passing through C, it retraces its path. So, it is the reflected. Now, what are the two reflected rays? One is the reflected ray MF, that is passing through F, and another is NC, that is passing through C. So, these two are now intersecting at the point A dash. At the point, this is the point A dash at which it is intersecting. So, A dash B dash is the real and inverted image formed. Now, look at the distances that we measure. From the pole to the object, that is BP, is the object distance, and because object is to the left side and in front of the mirror, it is minus u. And B dash P, this distance is the image distance, and again image is formed to the left of the mirror, and therefore it is again minus. All distances measured to the left is negative, therefore it is minus v. Then from the focus to the pole, the distance is small f, and that is focal length. So these are the three distances. Now look at the triangles A dash, B dash, F. A dash, B dash, F. A dash, B dash, F. So this is the triangle, and then MPF, MPF. So this is another triangle. Now these two are similar. How they are similar? Look at this. So this is how they are similar. So when they are similar, then the corresponding sides are the same. That means the ratio of the corresponding sides are equal, and all angles are equal. So this angle, this angle, this angle. So all these angles are equal. So we have the corresponding sides. Let us take. When you consider these two triangles shaded, I have shaded them. So A dash, B dash, F and MPF. So if I consider the ratio of the corresponding sides, B dash, A dash, so this is this, B dash, A dash by MP, this side, is equal to B dash, F. So this is this side by FP. So this is this side. So these are the ones. Then B dash, A dash by MP is same as BA. Look at this. MP is same as BA. Therefore, you can replace that MP with BA. So I replaced it with BA. Therefore, B dash A dash by BA is equal to B dash F by FP. Then look at these triangles. Angle APB and angle A dash PB dash. Angle APB, this angle, and angle A dash PB dash. A dash PB dash. So this angle, these two angles are the same. That means rule number 4 that I discussed, if there is a light ray which is oblique incident at a certain angle, it will reflect with the same angle. So the rule number 4, previous videos you can watch. The right angled triangles, these two are right angled triangles, as you can see here, these two are right angled triangles, and therefore these are also similar triangles. So these are also similar triangles. Therefore, let us put this as equation 1. Then B dash A dash by BA, I can write it as B dash P by BP. B dash A dash from these two triangles, considering the corresponding sides from these two triangles. B dash A dash by BA is equal to B dash P by BP. That gives you equation 2. Comparing equations 1 and 2, how do you compare? The left hand side of equation 1, left hand side of equation 2 are the same. Therefore, you can equate the right hand side of the two equations. Therefore, right hand side is B dash F by FP is equal to right hand side of the equation 2 is B dash P by BP. So you have this. Now what is B dash F? From the diagram, look at this. B dash P. So this is B dash P. That can be written as, I have written here. Look at this. B dash P is B dash F plus FP. Therefore, B dash F is equal to B dash P minus FP. So, how did you get this? From here. So, B dash P is equal to B dash F plus FP. So, this minus this will give you this. So, that is B dash F is equal to B dash P minus FP. Now, what is B dash P? We have written here in the beginning. B dash P is minus V, BP is minus U, FP is minus F. So, now we are going to substitute in those terms. So, you have minus V minus of, this is minus F by minus F is equal to minus V by minus U. Now, simple mathematics will tell you minus V minus of minus plus F. So, by minus F is equal to minus gets cancelled. So, V by U. And then V minus F by F, V minus F by F is equal to V by U, or by cross multiplying you get V minus F into U is equal to Vf, or multiply Vu minus Fu expand is equal to Vf, then this you will get this equation. Then by dividing with this Vuf throughout this equation, then you can cancel out these expressions Vu, Fu, Fv, Fv. Then you get this equation. So, this is your mirror formula. Now, using this mirror formula, given these values, either object distance and image distance, focal length can be found out, or focal length and object distance are given, image distance can be found out, and either of the two you have to have, then the other third parameter can be found out. So, this is very helpful. Now, in order to get the nature of the image, we require magnification. Now, what is magnification? It gives the size of the image relative to the object. It gives the size of the image relative to the object, which means it gives the extent to which an image is enlarged with respect to the object. So, how much size is enlarged of the image with respect to the object. So, that can be understood. Now, it is given by the ratio of the height of the image. I have used the notation h dash by height of the object h. Now, sign of this m depends on, basically h is always positive because height of the object is always above the principal axis, therefore, it is always positive. H is always positive, therefore, it depends on sign of the image h dash. Now, h dash, if the image is real and inverted, if the image is real and inverted, look at this. If this is the real and inverted image, if the real image is real and inverted, image is formed on the same side as that of the object, and image is below the principal axis, and image is in front of the mirror. Therefore, h dash is negative. And if the image is virtual and direct, then image will be like this, that we have seen in the beginning. So, it is above the principal axis, it is behind the mirror, and then it is erect. Therefore, it is positive. It is positive. H dash will be positive. So, based on those conditions, we can now tabulate this like this. So, m, the sign of m depends on the sign of h dash. So, if h dash is negative, m is negative. When will h dash be negative? If the image is real and inverted. And if h dash is positive, image is virtual and direct, then m will be positive. So, this is what it is. Now, with these things both combined, mirror formula and magnification, we can find out the size, nature and position of the image, and distances can be measured. So, if m is greater than 1, if m is greater than 1, obviously h dash will be greater than h. So, h dash is greater than h means what? height of the image is greater than height of the object. That means it is enlarged. Image is enlarged. If m is equal to 1, h dash is equal to h. That means same size as that of the object. And then if m is less than 1, then the ratio h dash by h is less than 1, which means h dash is less than h, which means it is a diminished image. Height of the image is less than height of the object. Now, because most of the times we don't know the actual heights, m magnification can also be expressed by the ratio of image distance to object distance by this formula minus v by u. Hence, because m is equal to h dash by h and m is equal to minus v by u, m can be written as h dash by h, which is equal to minus v by u. So, using these two formula, mirror formula and expression for magnification, one can find out the nature and different distances in spherical mirrors. In the next video, I will be discussing few problems based on this mirror formula, how mirror formula and magnification can be used to get those various distances, etc. Till then, keep watching, keep learning. Thank you.